China launches spacecraft to collect samples from dark side of the moon. The Chang'e 6 spacecraft took off on a long March 5 rocket from the Wenchang Satellite Launch Center on Hainan Island at 16:27 on May 3, Hanoi time. During its 53-day journey, Chang'e 6 will head to the South Pole-Aitken Basin, SPA, on the dark side of the moon, which cannot be observed from Earth, according to the China National Space Administration, CNSA. The mission will collect 2 kilograms of lunar soil and rocks from the landing site for detailed analysis. The sampling process will be aided by the Chang'e 2 satellite launched in March, currently orbiting the moon and awaiting Chang'e 6's arrival. Chang'e 6 was initially developed as a backup plan for the Chang'e 5 mission. In 2020, Chang'e 5 successfully transported 1.73 kilograms of samples from the lunar surface. It marked the first lunar rock samples returned to Earth since the U.S. Apollo and Soviet Luna missions 5 decades ago. According to Jonathan McDowell, an astronomer at Harvard University specializing in rocket launch monitoring, Chang'e 6 is essentially a repeat of Chang'e 5. The only addition is the communication link with the dark side. Similar to its predecessor, Chang'e 6 consists of 4 parts: the orbiting spacecraft, the lander, the sample collector, and the ascent module. The lander and sample collector will head to the lunar surface, while the orbiting spacecraft and ascent module will remain in space. They will touch down in the northeast region of the SPA, known for its complex geology and high scientific value. After collecting the soil and rocks, the sample collector will take off, return to lunar orbit, and transfer the samples to the ascent module for the journey back to Earth. Last year, a Chinese scientific team identified 3 potential landing sites for Chang'e 6 within the SPA, a giant basin 2,500 kilometers wide and 8 kilometers deep formed billions of years ago by an asteroid impact on the moon. According to remote sensing data, the sites are diverse in age and chemical composition. The spacecraft will select the safest landing site as it descends. Chang'e 6 is likely to find and bring back basaltic rocks, dark-colored igneous rocks abundant in the SPA following volcanic eruptions. Scientists can precisely determine their age, composition, and formation processes. By comparing them with rocks from the lunar near side, they may unravel clues to why the moon's hemispheres are so different. Understanding the dark side of the moon is crucial, especially because the moon has distinct bright and dark sides, said Ross Mitchell, a geologist at the Institute of Geology and Geophysics in Beijing. While the near side is rich in young volcanic flows and has fewer ancient crater formations, the far side retains its rugged topography with numerous ancient craters. Chang'e 6 also carries scientific instruments developed by international researchers, including the detection of outgassing radon, DORN, France's first lunar instrument. The device uses radon gas emissions to study the moon's extremely thin atmosphere. Compared to Chang'e 5's 23-day journey, Chang'e 6's flight will be much longer as the spacecraft spends more time in lunar orbit before landing. The spacecraft is expected to reach the moon on May 7, and the samples will return to Earth on June 25. We hope you found today's episode informative and engaging, and we look forward to bringing you more fascinating stories and insights in future episodes. Be sure to subscribe to stay updated and join us for our upcoming episodes. Thank you once again for being part of our community. Until next time, stay curious, stay inspired, and we can't wait to reconnect with you in the next episode.